Hello and welcome to discussion week 2. First, I'm going to go over some logistics. So, participation starts this week. You can either go to lectures or contribute some thoughtful and unique comments on the course website. Project 1 will be released this week. I believe it was released yesterday, and it'll be in 2 weeks, which is February 16th. It mostly focuses on rasterization and texture mapping, a lot of which we will go over in this discussion. And lastly, project parties start this week, so if you need help or if you want to work with other people, please come to those. Okay, and then the agenda for today, we're going to talk about sampling and aliasing, the Nyquist theorem, transforms, and texture mapping. So in this video, I'll talk about sampling and aliasing, and then in the next couple, we'll do a couple problems on the discussion worksheet, and we'll move on to the next topic. So first, what is aliasing? Here's some examples of aliasing. As you can see, these lines look more like staircases, which are normally called jaggies. So this is due to undersampling the signal that we want to recreate. So if you think about it, the real world is continuous and our computers are digital and discrete, so we have to sample this continuous real world in order to make it discrete, and if we undersample, that's when aliasing happens. So here's an example. Let's just watch this video. As you can see, it looks like this helicopter is just floating up in the air because the camera shutter speed and frame rate is exactly the rate of the helicopter's rotor. So this is a pretty cool example of aliasing, since the real signal that we're trying to create is the helicopter's rotor actually spinning, but we're undersampling it, and so it looks like it's just staying still. So now let's talk about the Nyquist theorem. So the Nyquist theorem essentially tells us how much we need to sample in order to avoid aliasing. So the Nyquist frequency is defined as half of the sampling rate. So this essentially will tell us, for a given sampling rate, what types of signal that we can handle without aliasing. So for example, if your device can sample at 100 Hz, then the Nyquist frequency is 50 Hz. And the Nyquist rate is just the opposite of that. So for a given frequency of a signal, this will tell you how much sampling you need to do. So say you have a signal that is 20 Hz, then you need to sample at least 40 Hz or above. Actually just above. So this tells us essentially 2 ways to avoid aliasing. We can either increase sampling such that we are above the Nyquist rate. So if we sample at more than twice the signal frequency, we will not have any aliasing. Or on the other hand, we can filter our signal by cutting off all frequencies that are greater than half the sampling frequency, and we can keep our sampling rate the same and additionally avoid aliasing. So now we're going to move on to the worksheet.